This morning on Client's Garage, we're working on a 2024 Woodmizer LT50 wide super hydraulic with a remote head. So I was getting an error on the main operator interface panel for check cable and breakers. So I had the carriage would come back, the carriage would go up and down, but the carriage would not go forward. So the issue ended up being the linear encoder was failed internally, which the power 24 volts must have been shorted to ground internally, which was drawing the system voltage down. So we're going to go through a little bit here on how we determine that. So this section of the prints, you can see like there's a CAN bus communication system. I believe it stands for controller area network. It's just a type of communication. So this is your main operator interface panel, and you can see pins 2 and 3 are the ones that have that CAN bus communication. That comes over to this section, right? Say 3.304 for our CAN bus. That is in parallel with a transducer, meaning that this cable set comes into J1, houses the wiring for the CAN bus communication, which is only really 2 wires, and then your transducer. So that's what tells the head what the position is, how far off the deck you are. So the H-bridge module has CAN bus communication module in it, as does the main control panel. So this would be your connector, and it's these 2 wires are for your CAN bus communication. The rest of these go down. One picks up power down here. The other 2 go to the forward and back and up and down. You can see the wiring here comes around. If you read your print, there's your ground, and then we're coming to our drum switches for up and down, and then coming across the forward and reverse as well through the circuit eventually. So those come in on a different harness, but same principle. So that's most of the time this issue, from what I was told by Woodmizer, is through the cat track cable through high flex. The cables break internally. That will be this wire coming across here, and eventually that wire makes its way on through, comes up and through this connector, which comes up to the top of your H-bridge module. So initially they said right away, check your breaker, see if you have power, 12 volts DC here, and I did have 12 volts DC here. They said that's another problem, that the high current, 12 volt high current solenoid here, this is your main control power, that internally either coil burns open on it, or you get bad contacts, which causes 12 volts or less than 12 volts to reach the H-bridge module itself. So if you don't have 12 volts here, that could be a problem. With this situation, when I would hit the up and down, the motor up and down, lights would come on, and the output motor light would fire here. When I would go in reverse, it would come back. The switch input picked it up, motor output picked it up, but when I went to go forward, the switch input light came on, which that told me that the drum switch was working, but the motor output light never came on. So we know that there was an issue with the control power. Now going forward, you're going through the potentiometer, which is here, your potentiometer speed control. So what led us to figure out that there was a drop in voltage was the center pin on here did not have 5 volts DC. This is a single turn 1K or 1000 ohm potentiometer. So your center pin should have 5 volts on it, and then those 5 volts, through adjusting the speed control, the resistance changes, which changes your voltage, and then that voltage goes back on your purple wire and your brown wire here, and eventually it makes its way back through the harness, and in that harness it'll bring your slightly reduced 5 volts to here, to your H-bridge module, which will give you a specific drive speed on going forward. That's how you control the carriage speed. So what I did was I took the connector off and pinned it out and figured out which one it was here, and then I checked for continuity, basically to make sure the wires weren't broken, and they were good. So we only had like approximately 2 volts on the wiper or the center post on that potentiometer, so that led us to believe that there was an issue somewhere else in the circuit that was drawing voltage down. So the linear encoder is 12 volts. I'm sorry, it's 24 volts, standard, more standard industrial DC power voltage. So basically, there was a short internally inside the transducer, which is drawing the 12 volts down, or 24 volts down, which reduced the 5 volt output through the potentiometer, so we weren't getting the correct voltage coming back for your speed control forward. So that ended up being the problem. Normally it's not as complex as this. However, this is one solution and a short troubleshooting process. So just an overview of how the system works. As always, have fun, stay safe.